Now that I've got my graph into my report, I need to talk about what I'm seeing and what the data is telling me about whether or not Year 9s or Year 11s tend to run faster. And so I need to start answering some of these questions, starting with the idea of just what do I see? So the first thing I'm going to talk about is center. Which group has a higher mean and median? So our center are our averages, our means and our medians. And the median is the middle vertical line in each box, and the mean is the red dot. I've also got the exact numbers, but I'm going to save them till later to look at. So just visually I can see that the mean and the median for Year 9s is higher than the mean and the median for Year 11s. So I can have a sentence about the center that says that the mean and the median 1500 meter race time for Year 9s is bigger than the mean and median race time for Year 11s. So this one is now complete. Then I can also talk about spread. So there are two ways we think about spread. One is the complete range, so the lowest and the highest values of each group. But another one is the interquartile range, or the size of the boxes in our box and whisker graph. And if one group is narrower than another, we say that the data is more consistent. It's more centralized around the median. However, I can see in this graph that both the boxes for Year 9s and Year 11s look to be pretty much the same size. They might not be exactly, but visually they look very similar. So I'm going to say that. That the boxes for the Year 9 and Year 11 1500 meter race time data are very similar. This indicates that the data for each group is as consistent as each other. So consistent is the key word here. So now this one is done. Shape. Is the data left skewed, right skewed, or symmetrical? Now this can be a really tricky one, and like I said, you can go back to your graph and chuck the outline over to kind of give you some help. When I'm looking at the Year 9 data, generally it looks pretty symmetrical. Here's the middle. Yeah, it's a little bit longer on the left tail, I guess, but generally it's fairly symmetrical. Whereas in the Year 11 data, you can see most of our data is here, but there's got this quite long right tail on the side here. So in terms of the shape, I would say that the Year 9 1500 meter race time data appears to be symmetrical. The Year 11 1500 meter race time data appears to have a right tail, indicating this data is right skewed. So that's this one done now. Now the overlap, this is probably the hardest one, but I need to find what I'm calling the 75% 50% overlap. So that's, can I find in my boxes somewhere a place where 50% of the group is bigger or smaller than 75% of another group? And actually I can see that here. I can see that the Year 11 upper quartile is just below the median for Year 9s. So these three segments here represent 75% of the data for Year 11s. These two segments up here represent 50% of the Year 9s. So in this case I can find that overlap, and how I would say it is like this. I can see that 75% of the Year 11 1500 meter race time data is less than 50% of the Year 9 1500 meter race time data. And again, that's because these three segments, 75%, is smaller than this 50%. Then I can also go into the next section, is what do the numbers say? So it's answering these questions. I can get rid of this overlap one now. What do the numbers say? Well, first of all, let's look at our medians specifically. So that data or information about specifically the mean and the median, I can read here. Here's the median for the Year 11s. Here's the median for the Year 9s. And I can write that in a sentence where I need to say which one is bigger and by how much. So that sentence can look something like this. The median 1500 meter race time for Year 11s is 6.31 minutes, which is 0.83 minutes shorter than the median Year 9 1500 meter race time of 7.14 minutes. So that's the medians talked about now. The means, what are the means, which one's bigger and by how much? So it's like the same sentence, but now we're talking about the mean, which is these dots here. And again, I can get the exact numbers from my summaries on the left of my graph. And so a sentence for this one would look something like this. The mean 1500 meter race time for Year 11s is 6.42 minutes, which is 0.67 minutes shorter than the median Year 9 1500 meter race time of 7.09 minutes. So there's some calculations that are needing to have been done there. So that's that one. Next is the interquartile range. So the interquartile range, as I kind of mentioned before, is the size of the boxes, the actual number though of how wide they are. And we get that by calculating the upper quartile, subtracting the lower quartile for each one. And whoever's got the smaller number has the more consistent data. But what we see in this one is the interquartile range for the Year 9 1500 meter race data is 1.45 minutes, but for Year 11s it's 1.49. So because both interquartile ranges are very similar, this is further indicating, as we saw visually, that both groups of data are as consistent as each other. So now that one's done. And then the last one is to talk about shape. So for each group, are the mean and median similar to one another, or is one higher or lower? And what does this mean in terms of the shape of the data? So you can kind of see visually that the mean and this mean is a little bit lower, but it's very, very similar. And then we can check that in the numbers and see that they're very, very similar. And for Year 11s, you can kind of visually see that the mean is a little bit higher, or more obviously higher. And this is a little bit backed up in the numbers. They are very similar. So in that case, we would come up with a sentence a little like this, that the mean and median for Year 9 1500 meter race data are very similar, indicating the data is symmetrical. The mean and median are also similar, or this should say for Year 11s. However, the larger mean could indicate a slight right skew. And with that, that is everything that I need for my analysis part.